There we go. So why don't we just get started with the introductions and go on to the next slide. Welcome, everybody. My name is Vernon Keenan. I'm a senior industry analyst in Salesforce DevOps primarily, and focus exclusively on the Salesforce ecosystem. I have a website at salesforcedevops.net. I've been in the Salesforce ecosystem as long as you possibly can. I was actually hired by Mark Benioff at Oracle in 1995, and actually renewed my friendship with him at the last Dreamforce. So it's been quite a 30-year ride with me and Salesforce. I've seen the entire arc, and it is a very this agent force thing that just happened. It's very exciting, and I can't wait to share some insights with you guys about that. So I think my background is I'm from Midwest North America. I went to Chicago, Northwestern University. As a youngster, I worked at Genentech. I worked at Oracle, like I said, and also Salesforce as a consultant early on. I actually worked in the Telegraph Hill historic house there with Mark early on. So I think with that, turn it over to Ivan.
Wow, that's going to be hard to beat. I love speaking with you, Vernon, but you always surprise me. I didn't realize you worked in One Telegraph Hill. That's amazing. So I'm Ivan Harris. I'm the Chief Product and Technology Officer at Provar. I've been here a couple of years. Been in the Salesforce ecosystem for over 10, mainly as either a CPO or CTO of Salesforce ISVs. This will be the third AI platform that I've brought to market. I've been working with AI for over 8 years now. And during that time, I also worked for Salesforce. So both Vernon and I are alumni, which is a nice thing to learn. I worked for Salesforce as a senior program architect down in Australia for a couple of years before joining Provar. And we're going to be sharing with you our knowledge about AI and how it impacts test automation, but you're also going to get a glimpse of the direction of travel that Provar is going in.
Yeah, I'm really excited about every Provar customer on the line here today is going to be excited to see that roadmap. So let's kick it off here, Ivan. You and I were talking earlier, and I'd like you to kind of give us the whole reason why are we talking about this? Why is test automation important? Somehow we got to tie it back to the reason why we're employed by a company or an organization or a government. We have constituents, we have shareholders, we have customers. These people need to be serviced, and they need to get results, and we're creating applications that make all that happen. And now Salesforce is creating applications that are critical, like banking systems or healthcare systems or other types of systems. And so we need this, ironclad armor to protect, our applications. So I think I just wanted you to kind of go through that thought for enterprise apps.
Yeah, so if we think about enterprises in particular, I think the key driver for this is digital transformation. Digital transformation has been going on for quite a number of years now. As you know, it got accelerated during COVID when a lot of people had to start working remotely. And if you think about digital transformation, you're trying to deliver better experiences for your customer, and you're trying to deliver new ways of working for your business to try and be as competitive as possible. So when it comes down to delivering better experiences for customer, it centers on brand reputation. You want to build your customer base, you want to retain your customer base, you want them to be advocates to draw more customers. If they have a poor digital experience, then it can have the opposite effect. And likewise, for running your business, all businesses are trying to be as competitive as possible, do more with the resources they have available. So they're driving through new ways of working through digital transformation. So Uh, so if I look back at some of the projects I've worked on with in digital transformation in regulated industries, they've typically been organizations that have got Salesforce as one of their strategic platforms. So we do test automation with Salesforce, but if you start thinking about those those user journeys and the business processes, they don't just live in Salesforce. They integrate with and connect with other systems. So the journeys that people experience traverse multiple systems. So you have multiple systems, you may have multiple Salesforce orgs, you may have multiple teams. Some of our customers have got dozens of Salesforce orgs and they've got
Mm,
a number of SIs working with them. They've got their internal center of excellence. So all of these teams are pushing changes and new apps into these orgs in an agile manner as frequently as they possibly can, so they can incrementally deliver value to the business. When you start doing that, you need to have this ironclad security that the changes that you're making aren't going to break stuff you've developed already, particularly when it's happening across multiple teams. So regression testing in particular becomes very important so that you can ensure that you haven't broken anything before you deploy to the higher level environments and ultimately to production. But you've also got to start shifting left because we all know that the evidence points to the earlier you find an issue, the cheaper it is to fix. So anything you can do with test automation that shifts left into the development team and even before that into the business analysts and the product owners um, improves the chances of your quality. So you can start releasing at higher rate, more frequently, and with the assurance of higher quality.
great. So I think what you're emphasizing there to kind of take another point is that test automation has kind of elevated itself to kind of this platform engineering status where you need to use it now, especially in larger organizations, as a way to ensure that you have like cross silo capabilities, like the ability to, like you just said, to connect systems together, just getting increasingly complex.
Mhm.
And that's actually one of the biggest challenges, right?
Yeah, no, exactly, because you can't have silos of quality in your organization. You can't have one of the systems that you're working on having a higher level of quality than others because that or if another system does not have that level of quality, it's the weakest link in the chain, and the whole house of cards can come tumbling down. So one of our customers recently shared a case study where they were showing how they were testing a six system digital signature journey for an
Uh-huh.
insurance claim. So that was a true end-to-end journey going through multiple systems that included API testing, database testing, UI
Right.
testing, and you have to have a green light on every single one of those systems. And then you start pushing into multiple higher level environments, and you have business owners who are responsible for those business systems. For example, if you're in a bank, then the business owner for corporate investment banking will have a higher level of regulatory compliance requirements than the leader of the retail banking division, for
Mhm.
example.
Right.
So, in addition to the test automation, you have to have a way of layering a layer of governance on top of that as well. So you can show that each of the systems is functioning and on green, that each of the customer journeys is on green, and
Mhm.
each of your business processes is on green. And then the business owner will be happy to press the button and say push to prod.
Excellent. So I think that kind of set the stage for the kind of complexity that we're dealing with in test automation. And now we're going to start talking about AI finally. But so I just wanted to, for our audience here, first of all, just kind of remind everybody we've got the Q&A and you and the chat. Love to hear where you guys are from, and if there's anything as we're talking, if there's any commentary from the audience, we'd love to hear from you. Also, if you want to submit a question for the end of the webinar, please use the Q&A button on the screen there, and we will be able to manage and filter those as we go along. So I think go to our next slide. And then now we're going to talk about large language models. And let me get my throat clear for this. All right. So how do we talk about this in terms of Salesforce and testing and all that kind of stuff? I think I just wanted to kind of make sure that I just want to share some key insights, I think, into the large language model that's very relevant, that kind of helps everybody understand how to use them better. Is that these large language models and the transformer architectures use this thing called a neural network. And the neural network basically emulates the way that we understand the human brain operates. And this is by creating synaptic connections between cells of various weights. So, what happens is that we've learned how to take knowledge and information and encode it into a multi-dimensional array of numbers that represents that little bit of knowledge in this n-dimensional space. I hope I'm not losing people here. So where we go with this is that I can take all kinds of information, and this comes at scale. So if I take knowledge, little bits of knowledge, like literally 1K bits, 1K bytes of text, for example, and figure out, or even just one word, and just figure out exactly what the meaning of that is in this n-dimensional space, and do that literally a billion times with a billion different bits of information, it turns out that what you've created is a learning machine. And this learning machine can just innately take in now new information and know how it is connected to all other information that it's already taken in. So that's one of the key insights is the neural network architecture. And this actually was originally derived from computer vision technology. So it's the same, and we learned about this biologically from studying how the eyes work and how the back of the brain, the visual cortex works. And now we'll get back into computer testing. These developments, the general neural network technology and the cognitive ability to understand semantic relationships, because when we categorize everything, that becomes semantically categorized. By that semantic, it means what kind of knowledge it fits into. So if you're trying to understand large language models and how they work, the idea of semantic classification is key. So that then is how vision technology is able to work as well. So getting back to how it's revolutionizing testing, instead of now understanding how you would perhaps run a test based on a screen architecture where you would label buttons or create other types of layouts similar to how Selenium works, for example, where you have explicit layout information tied to your testing. Now you have it laid out in a visual way where you say, I'm going to hit this button on this part of the screen. And we've seen this already in several products out there, such as ExcelQ and Kapato robotic testing and things like that. And that's what they're doing. They're using computer vision technology, computer vision, artificial intelligence to achieve this. And that's also what UiPath and all of the robotic process automation, RPA technology, is similar to that as well. So these are some of the key things that are revolutionizing uh, computer testing. And by revolutionizing, I mean that it is so powerful. It has the power to actually put other ways of doing it, making it obsolete. And I'll just pull out one example of that. So forever we wanted to do natural language processing, right, in database technology. So if you have a big database, you want to be able to, give a natural language query into it and have it come out. And we've been working on that my whole career, my whole 45-year career that we've been working on that. And that has only worked in the last 2 or 3 years because of a large language model technology. So it has completely revolutionized NLP, in other words, obsoleting all of the old ways of doing it. And the rate at which companies like OpenAI and other Anthropic and Google are advancing and what they're actually doing, these companies have the ability to offer new technologies that allow startups and maybe established companies also can adopt these technologies, but it allows them to leapfrog in capabilities, kind of like beating other companies' old intellectual property very quickly. So that's what we mean by revolutionizing, to be specific. And that is definitely happening here. That is the march of the large language models. Well, that was Google asking, excuse me. So let's go to the next slide. So I think, Ivan, we want to talk about how we're using this technology now.
Mm. Yeah. So is there a slide before this? Because I think we were going to talk about, there we go.
There we go.
Because we're going to transition from generative AI to predictive AI in the next slide. So um, as Vernon mentioned, in 2022, OpenAI released their first LLM, and that really started this march that he referred to, where it started democratizing access to AI. So more and more businesses are able to build AI into their products without requiring a huge team of machine learning engineers and data scientists to be able to do that. And if you think about both the software development life cycle and the testing life cycle, we take the testing life cycle first. You go through your planning, your design, your authoring, your execution, and your analytics phases. So each phase of that journey, there's opportunities for AI co-pilots built on generative AI to assist to make that phase more efficient, effective, and accurate. So if you've played with ChatGPT or with Agentforce or Copilot, its predecessor, then you'll know that what you need to do is generate prompts. And prompt engineering and how to generate prompts is a bit of an art. There are some solid guidelines on the internet if you want to Google for them. But asking the LLM a question in a way that gives you an appropriate response back is the key to this. But once you figure that out, and because the LLM is built on a corpus of public domain information from the internet, huge amount of information, you can ask it questions in natural language and get a response in either text or audio or video, etc. So in our case, which we'll come on to later on, then you can do within your testing lifecycle what you would typically use ChatGPT for. So I use ChatGPT to go from a blank piece of paper, and I've got an idea in my head about what I want to produce, and I ask it, generate a prompt, which is asking the LLM a question, and then it will produce something which is 80% there. And there's still an opportunity for me to apply my own personalization and style to that. And the same thing is true for each of the stages of the testing lifecycle when using generative AI. So when you're at the planning phase, for example, you can lay out what your business goals are. You can define what the systems are that are going to be tested, how they're interconnected, etc. And you can ask the LLM to create you a plan. So a lot of the work that's gone into that is not building the LLM, it's asking the LLM the right questions. That's where we spent most of our time, was in prompt engineering, so we could get the right responses back. I won't
That's
explain
fascinating.
everything.
Ivan, you're talking about using the chatbot as like a executive thinking partner is when you're doing your planning.
Exactly, exactly. It's not quite at the virtual estate level. It is like how can I do my daily job and achieve something in minutes instead of hours? So we've shown that going through and timing it from creating a testing plan, creating a risk mitigation plan, designing your test cases, creating test automation steps, executing your tests as efficiently as possible, and then doing the analytics, you can cut a multi-hour journey down to minutes without losing the ability for the either the business analyst or the product owner or the test engineer to apply their own expertise to take that 80% to what we want. But it gives you a real big leg up.
Excellent. Let's go to the next slide. I think talk a little bit about how we've been using AI for a while, right? I mean, and it's been useful in kind of this predictive phase. Because we're looking at AI in these phases all the time. Like we have a predictive phase, we have a generative phase, and I guess we're dawning on the agentic phase.
Yeah, no, exactly. So I've been through the full life cycle that you've just described there, Vernon, in previous platforms and products. We started with generative AI because of the democratization that OpenAI gave us, and also the toolkits that you can get with AWS, which is our platform of choice. Um, so just to step back a bit, generative AI allows you to create new content from existing content, broadly speaking. Predictive AI can make recommendations, form predictions, and do classifications by looking at historical data and trying to identify trends. So a great use of predictive AI, for example, is looking at how historically tests have performed and how you've had to go back and rewrite tests based on changes to requirement, changes to code, etc. So you can predict, for example, if anybody changes this particular area of code, it's more likely than not to have a bug introduced into it because of the complexity, because of it may be tightly coupled to lots of other parts of the application instead of loosely coupled and highly cohesive. So predictive analytics allows you to look at historical trends, historical data, and predict what a future outcome might be. And when it comes to testing, there are all sorts of uses of this. For example, you could use classification to produce heat maps of testing. So you can
Hmm.
have a visual representation of your test coverage, and you can have hotspots of where you've got really good solid tests, areas where tests are flaky, white space where you really ought to be adding some more tests, or areas where tests can be consolidated. So you may have 200 tests in a particular area, and by doing some refactoring, applying some best practice, you could reduce those number of tests to comply with best practice, etc. So that's an example of classification and clustering. And ideally, our goal is at Provar is for anybody involved in the quality life cycle, whether you're a business analyst, a capability lead, a business owner, a test engineer, is to come into work in the morning, is turn Provar on, and for it to have a prioritized list of things that you need to do that day to maximize the chances of either maintaining or improving the quality of your IT estate. And ideally, on the right-hand side, there's a list of things where the AI was so confident that the agents, which we'll come on to, were confident enough that they were able to automate it on your behalf while you were sleeping. So having a blend of agentic, predictive, and generative AI and using it for the correct use cases in test automation will give you some significant benefits.
Uh, Actually, why don't we take a moment to kind of pull back and talk about agents just a little bit? Because I think everybody's interested in that in the agent force stuff that's going on. I
Mm.
think I can share some information that I learned at Dreamforce and talking to executives and other folks in my research. And um, it turns out what they're this Atlas thing that they're working on is kind of like a super agent, so to speak. It is. incorporates kind of like this mixture of experts type technology where you can approach a general problem by having a large language model that kind of supervises other specialized large language models.
Mm.
So if you give it a general task, it will be able to decide which expert to assign a part of that task. And that's kind of actually how Agent Force works now with the actions, except the
Mhm.
actions aren't really, they're well defined. They're completely deterministic. It's not another large language model doing an agent thing.
Mm. Mm.
But that is actually Salesforce has a large investment in this area. And just before Dreamforce, they announced something called a LAM, a large action model. And what the large action model is specifically designed to do is to activate APIs
Mhm.
specifically. So that would be a perfect way to take like a Swagger file from a MuleSoft integration or something like that, and then it would then have that whole catalog of API calls available to it now as actions. So that's
Mm.
I just wanted to mention that that's where we're going, and it as a like I've been following Salesforce for years, and as an analyst, that I'm born to be skeptic. So I have to be convinced on all this stuff. But this research, the Atlas research, the large action model research, their ability to kind of move forward with Agent Force and to kind of make it this tangible thing right now is actually pretty exciting for the Salesforce ecosystem right now.
Yeah, and I think I totally agree, Vernon. And I think the reason why companies like Salesforce and ServiceNow have been so quick to adopt and able to adopt agentic AI is because of the underlying capabilities in their platform they've developed over the years. So the actions you're talking about can be a flow, it could be an Apex class, it can be a call to an API, it could be a call to another agent, another model. So they've got all of this capability already. So to slap an agent on top of that was relatively easy for them compared to a pure startup. And the example, the analogy I like to use for agents is imagine a kitchen in a restaurant, and you got Gordon Ramsay there, and he has his army of chefs, and each one is a specialist in a particular area. So one is great at pastry, another one is great at meat, another one's great at fish, etc. Another one great at vegetables, and each of those chefs is like an action, and they're able to do their job really well. Very narrow. They don't know how to do anything else as an expert, but they know how to do their job at their station extremely well. And Gordon Ramsay, the head chef, is like the agent. And as you said, the first thing you do is you assign
He's
a task. So
Atlas.
his
He's
task is to
Atlas.
make is he's Atlas, and his task is to make sure that great food to the appropriate quality reaches the pass to get to the customers in a timely manner. And he orchestrates all of those other activities to make sure that that happens. And that could extend further that analogy. With Salesforce, you could be connecting to supply chain systems, to ERPs, etc. So in the restaurant, you're getting the right ingredients coming in the right volume and the right quality just in time for them to be able to do their task. So agentic AI is very exciting, and it just unlocks a completely different level of capability because then you're talking about having your virtual assistant that you can give a task to and say, go and take care of that while I get on with some more complicated
Mhm.
human in the loop tasks.
I think we'll know the agent stuff is real when you can just ask your iPhone to book a flight for you, and it'll just do it.
Mm,
Uh,
yeah.
so let's go to the next slide. Oh, I think there we go. So I think The thing I wanted to refer here is I referred earlier to the LLM's ability to take to learn essentially. They've already been trained with literally trillions of little bits of information, and they know exactly how new information kind of fits into that into any semantical structure of knowledge. And essentially, this gives LLMs transformational properties that are very useful for us in the Salesforce ecosystem. So I think I just go refer to Ivan's description earlier of the digital transformation problem, how vast it is, and then let's just kind of imprint that on somebody who's gone whole hog Salesforce to solve that problem, and they have like five Salesforce clouds and Tableau and blah and Slack and everything, and the cognitive load to be able to understand all of this stuff is is far beyond an individual's capability to do that. There is no longer a Renaissance man or woman or person in the Salesforce ecosystem who knows everything. I doubt that person now exists. That person might have existed 10 years ago. But after all of these acquisitions, all of these clouds, nobody knows everything. So you need a companion. You need a thing that knows everything, that has all of the documentation ingested. And then let's go the next bit, which is let's talk about how we manage SaaS products today. And there's a key thing that happens when people manage a SaaS product, which is to ingest all of the metadata and security information from the org and to cache it offline or in a uh, online system, doesn't really matter where, but that information is organized into what I call a digital twin of the Salesforce org. And this is happening more and more with how people manage multiple SaaS systems. So let's say you're managing ServiceNow or NetSuite or SaaS or Oracle, and you now can have digital twins of all of these systems. Like under one roof. I think that's kind of like the dream right now of enterprise platform engineering. And it turns out that once you have this digital twin and you marry it with the march of the large language models, you've solved a lot of problems in our world. And one of them is change intelligence. And by that, I mean, the large language models are able to understand XML and other JSON and other computer data that describes your metadata, your security rules, and all of that kind of stuff, and is able to understand the relationships between all of the elements in that array of metadata, just like how I was describing earlier, the semantic relationships. So it knows all about that stuff, and you can ask it to determine the blast radius of a change in your particular org. So you give it a bunch of metadata. You say, I'm going to use this to, update my org. And if you've properly ingested all of the data, and that's a tricky thing, it's not an easy thing to do, but if you properly ingested all of the org metadata, you can now accurately determine what parts of that metadata are going to be impacted by that change. So I think this is one of these revolutionizing aspects of LLMs, and it also impacts this thing about cognitive load too. To be able to ask if you've ingested all this information, now you can ask an LLM questions about it as well, and you can also ingest documentation, so you could ask questions how to fix things or how to change things, and it would know. So, Ivan, we've talked about this.
Yeah, and I think if you can get the synergies between multiple systems that are metadata driven, like change intelligence, so you can understand the blast radius, a CI/CD solution which understands metadata and how what the mapping is between metadata and applications. And if you have a test automation solution that's metadata driven, like Provar is, where between the three of them, they can pass information around to say, this is a requirement that has been created or a change in requirement. Here's the metadata that is impacted. Make sure that your CI/CD system pushes through those changes into the target or based on change metadata, and ensure that the CI/CD system invokes the test automation to execute the minimum number of tests to get the maximum number of amount of coverage. And then I mentioned earlier on about shifting left, and one way this can help with shifting left. If you're a pro code developer, for example, um,
Let's
and
move on to
you,
the next slide. I think that's what we're talking about now.
yeah, okay. So we're going to digress very slightly, and we're going to talk about what we're doing at Provar, what we've got so far in terms of AI, and what's going to come. So it's
Oh, well,
very high level.
this is the most exciting part of the pitch here, everybody. So get ready.
So thanks, Vernon. I hope I live up to it. So if anybody wants more detail, if we were Salesforce, we'd have like a forward-looking statement coming up right now. We're not publicly traded, so we don't need one, but some of this stuff is future functionality. If you want to know more, and the future functionality is like deliberately very high level for obvious reasons. If you want to know more, DM me and we can set up a separate session. But if we can click to the next slide, please. If you look at Provar's journey with AI across capabilities, platform, and AI itself, in the past, the thing we're known most for is Provar Automation, our desktop individual contributor test automation tool. It's been in the market for 10 years. It's been very Salesforce centric. It's able to test multiple systems and customer journeys and business processes. We can test APIs, UIs, databases, etc. But that's our flagship product that we're best known for. And the capability that delivers is test automation. Then we released Provar Manager and Provar Grid. Provar Manager is our quality hub, and it sits on Salesforce and adds additional capability to take you from sort of test planning, test design, and analytics and reporting, integration with CI/CD systems and with test execution engines. And one of the test execution engines is our own, which is Provar Grid, which allows you to do test execution at scale. So that full stack then gives you test design automation end to end. And that's what we've been using generative AI for, to assist in every step of that journey. And when we come on to the next slide, I'll show you the specifics. The future is we're building our Provar AI platform. We've been building it for the last year.
What's that, Ivan?
So
You're
Provar AI
building a new
platform,
platform in the cloud?
yeah, and you heard it here first. This is the first time that we've spoken about this publicly. A lot of our customers know it's coming. Our technology partners know it's coming. But this is the first public domain webinar where we've actually mentioned it. So this is our SaaS quality as a service platform. Um, and that allows
That's
us
very
to,
exciting. It's going to help people adopt the product, I think. So
for sure,
good
for sure.
job.
So yeah, thank you. So we're going to have, a web-based authoring experience plus a desktop-based authoring experience when that extra performance is required. Centralized repository for testing assets. But really excitingly is being able to integrate every application from our partners as part of that quality lifecycle management journey. So you mentioned change intelligence before, Vernon. We can integrate with Jira and other requirements management systems. But the next thing that should happen is that change intelligence, predicting the impact on your target system from changes to requirements or new requirements, then test automation, then governance, then release management, then observability to create this closed loop. So that's our target for quality lifecycle management. And because we're developing a platform and it's AI first, it allows us to embed agentic AI and predictive AI in there. So we'll have our own data lake, our own machine learning models, so that we can do
Ah,
classifications and provide insights beyond what's capable with generative AI. So
fascinating.
to the next slide and show what we have today in terms of AI. So if you look at the testing journey on the left-hand side, where you got
Hmm.
test planning, design,
So
authoring,
here's where we're
execution.
looking at the SDLC essentially, or the test automation journey.
Exactly, exactly. And we've got co-pilots, which are generative AI based for every step of that journey. Anything with a green tick on it is what we have today. Blue is in development, and the red circle is roadmap. And all of these will be finished by the 30th of April next year. So we have a co-pilot that can help you generate test plans, and if that test plan has got any risks associated with it, we can automatically generate a test risk mitigation plan. I've just noticed that it's wrong. It says test strategy generation. It should be test risk strategy generation. When you get to the test design, that is creating test manual test cases from requirements. If they're in BDD format, like gherkin, cucumber, etc., and you could say, as a salesperson, I would like to create opportunities and attach them to an account so that I can track all my opportunities across all accounts. It will generate a set of test cases for you, which you can continue to build out manually or go to the next step where we will generate the Provar automated tests
So
to
that kind
automate.
of brings up a general point right there. These are a lot of this stuff is generally speaking is still like engineer in the loop, right?
Absolutely, yeah, yeah. So it's, as I said earlier, it gets you from a blank piece of paper to 80%. And so it gets you past the writer's block, does the scaffolding for you, so you can then look at it and go, well, that's not quite the way I want it to be. You can then inject your human expertise into that.
Right. So
Um,
it's a
yeah.
scaffolding and blank slate eraser.
Exactly, exactly. And we'll generate multiple options for you to select from. And then you can go and edit if, as I said, if you want to enhance it. I won't go through each of the blocks, they're fairly self-explanatory. And on the side, every one of our products now has Provar Assistant in it. So this is an LLM where we've used RAG to enable you to ask in natural language questions on how to do things with Provar. It's been trained on our documentation, our knowledge base, our University of Provar certifications, etc. So you can ask things like, how do I connect to an Oracle database with Provar? And it will give you the steps that you need to do. So you've got somebody helping you every step of the way. And if we go to the next slide about what's coming next with our Provar AI platform, deliberately vague on here. We've been working on this for some time, but some examples of some autonomous agents that we can create. These are fairly no-brainers. Anybody would think of these. The first one is the Gordon Ramsay of testing, and that is orchestrating that end-to-end process. So instead of having a co-pilot for each step of the way, the
Hmm.
overarching agent will understand the context and the intent and pass that between the agents to achieve an end-to-end flow. So you can get a new set of requirements out of Jira and say, can generate a complete 80% complete set of test plans, test projects, test cases, test suites, test steps, etc., test data. So we can generate test data as well. And it will produce the scaffolding for the whole thing end to end. And then self-healing, if it, one of the key things about agentic AI is it monitors its environment, and it can
Mm.
suggest changes based on changes in the environment. That could be changes in business priorities, application requirements, target system changes, changes to adjacent applications that have been pushed by a different team, and then it can suggest ways to heal your existing tests so that you don't have to figure all that out yourself. And we do have more than 25 other agent examples. And you're limited by your imagination with agents. And the key is to make sure that it's a practical application of AI and it's not whitewash. And predictive AI, the predictions that I talked about before, I described a test coverage heat map.
Mm.
I described
Mhm.
coming in the morning and understanding and prioritizing things that you need to do. But my view is that most of those predictive AI things will not be surfaced up directly to a human. It will be a feed into the agentic AI to allow
Mhm.
the agent to make a smarter decision on behalf of the person. So there, you've heard it first um, from
That's
Provar,
fantastic.
what our roadmap is for AI.
So yeah, no, it's that's a lot. That's a big reveal that Provar is building essentially a SaaS platform that's going to incorporate AI for your customers in various ways to help them be successful, essentially.
Indeed.
And so I think one thing we didn't, let's go to our next slide. I think what's up. Yeah, one thing we should kind of kick around is something that's very useful, more in the SRE or operational aspect, is root cause analysis.
Mm.
Um, so I think that that's another thing that I found to be quite useful, just in a practical sense, where you can this to just be able to have, if you can have a context of your operating environment somehow, and
Mm.
then be able to take an error message or some sort of failure mode or something like that. There, people have found a lot of success in using large language models to optimize, to find the root cause of those things and get systems operational quicker. Um, have you heard
Yeah,
of that? Can we
100%.
think of any other trends?
Yeah, so just on root cause analysis, 100% right. So one of the things that we do at Provar in Provar Manager is our quality hub, and we pull in information for a wide variety of systems to give a single pane of glass view of quality, not just testing, but all aspects of quality. So we can pull in information from Code Analyzer, for example, PMD,
Hmm.
from performance and scalability testing solutions. So you got that one view. And the more views you have, the better chance you have of predicting root cause analysis. So one of the things we do, for example, is we can trigger and execute Apex unit tests, and if any of them fail, we can do root cause analysis on that and suggest changes
Hmm.
to your code. The work that we've been doing with Salesforce and the Scale Center team on performance testing, for example, is to time a line where you see performance issues and functional test issues
Hmm.
coinciding at the same time. And then you can double click down and find the root cause and have it suggested by AI that these are the things that could potentially be going wrong. Taking information from Scale Center, taking information from your tests, and suggesting ways that you can remediate performance
Hmm.
issues.
That's
And
got to
one
be
of the things
especially useful in Salesforce with the governor limits.
Oh, absolutely. Governor limits, row locking, any of those things that impact performance, number of fields on a page, having all of that information and being able to do root cause analysis and say, well, the most likely reason for this performance issue is because you've got too many fields on a page, or because you're getting row locking, or because you're hitting the governor limits for other reasons, so nested SQL queries, etc. Um, but then as you mentioned, Vernon, then it's yeah, you keep coming back to complexity, digital transformation, multiple systems, interconnectivity, complexity, 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 and anything you can do to help a human to diagnose what the root cause is of a system error in multiple systems, not just Salesforce, is a big lift. So root cause analysis is a great thing, but ideally you want to predict that something's going to go wrong before it goes wrong, and you have to do the root cause on it. So that's where
That's right.
predictive AI comes in, and you can start looking at how changes that are happening might impact the target system, and head it off at the pass before it becomes an issue.
I think the emerging trends are one thing to kind of reiterate is that the big API service providers, OpenAI and so forth, are advancing at a rate that is hard to deal with, honestly, if you're a vendor or a user, if you're trying to actually keep up with all of this stuff, it's very hard. Part of it is that they are advancing new things all the time. They just this week announced the new Vision API, which is
Mm.
going to impact testing. You
Hmm.
took a look at that. Ivan, what
Yeah.
would you have to say about that?
Yeah, it was incredibly exciting. So for example, you can fine tune their LLM using as few as 100 images and then it starts detecting those things. So, again, this is something that's democratizing vision analytics in testing. So it gives, we build a digital twin using metadata, as you mentioned before, Vernon, and having vision in the mix as well allows us to join the dots between the front end visualization, the back end representation of that
Mm,
page within Salesforce, and so we can have that metadata approach that we can share with other metadata aware solutions.
mm.
So it really sort of allows you to you'll be able to easily see when something has changed. So you can run your software twice and go, that has changed unexpectedly. We need to run the tests for that area and make sure that those tests still pass. I think it's a bit of a game changer. I mean, and I it's astonishing how quickly things change, as you say. And I think the
Right.
key for all businesses is to have a responsible individual who's reading those articles, attending the dev days, and trying to look for business value in everything that's being released by these companies.
Yeah, it's easy to get blindsided with this stuff nowadays. If you kind of got your head down working on older technology, that's what we mean by revolutionizing.
Mm.
And so that's definitely happening. So we're winding up here. If anybody's got any additional questions, please put them in. Let's go to our Q&A slide. Okay, yeah, we're out of time, so there we go. Ivan, the question is, what is the biggest problem you believe AI can solve for testing, given what's currently available?
I think the biggest thing that can solve is accelerating tests, the time it takes to write comprehensive
Ah,
tests, and covering edge cases that you probably not get around to. So there is a finite number of test engineers on the planet, and the number of systems that need testing is
mm,
growing. And with digital transformation, you need to generate a huge raft of regression tests as quickly as possible. So anything that can be done to accelerate that, to produce high quality tests with limited resources, is probably the biggest thing that we can help with right now. And then beyond that, it's predictive. It's sort of
mm,
trying to predict where the errors are happening, where to focus your development efforts, sorry, your testing efforts, so that you can make the biggest impact on the quality of your system with
mhm.
the resources that you have available.
I can't agree with that more, especially when you're talking about time to value, which to me is the biggest metric that we as IT system builders kind of need to think about. When we're charged with creating a system, how long does it take for that thing to start creating value in our environment? And that kind of translates down to why is Salesforce DevOps so slow? Why is testing running all these tests so slow? And if we can speed that up with autonomous activities, spawned off processes, whatever kind of technology wizardry we can come up with, that's going to make us better application deliverers and better creators of enterprise value, in my view.
Yeah, accelerating time to value. Perfect one-liner.
So that is it for today, everybody. Thank you for coming to our webinar today with Vernon Keenan and Ivan Harris. I'm from SalesforceDevOps.net, and Ivan's from Provar. And I hope if anybody's got any questions, want to follow up, you can DM either of us on LinkedIn, I'm sure. We're both easily reachable there. And also email, mine is vern@vernonkeenan.com. That's easy. And you can email me directly, and I'd love to meet anybody from here. And thank you for coming today.
And thank you, Vernon. It's been a pleasure.